This is for tutorial APGP, question number 3. So the first two terms of a geometric progression are 3 and minus 2. So because we know this is a geometric progression, we know that this must be A and this must be AR. Write down an expression for the sum to n terms and evaluate the sum to infinity. So we know that A is equals to 3. We know that AR is equals to -2. That means that we can solve for R, and we know that R is equals to -2/3. So what are we required to find? We are required to find Sn. So Sn, we use the formula. So it will be A, because R is mod R is lesser than 1, so we will use this formula over 1 minus R. Okay, I know A is 3, so this becomes 3 times 1 . And this is nothing but 9/5 1 minus -2/3 power n. Okay. Next, they want to find S infinity. So there are two ways you can go about doing this. So I'll show you the two ways. So method 1 is just applying the formula. So method 1 says that S infinity equals to A over 1 minus R. That means this is 3 over 1 minus -2/3. So this is going to give you 9/5. Okay. Method 2, okay, it'll be good if you understand the analysis. Alright, so can you see that as n approaches infinity, okay, so what happens? Right, if you look at this term, as n approaches infinity, we know that -2/3 to the power of n will go towards, okay, it goes towards 0. So when this happens, we know that Sn will go towards what? Okay, it will go towards 9/5 1 minus 0. Therefore, we know that S infinity is equals to 9/5. Okay, so this argument, it's concurrent. It's this that resulted in this, and this that resulted in this. Okay, and that's why S infinity will give you 9/5. Okay, so you can pause the video if you want to take down the solutions. Next, okay, so I will go through 1, 2, 3 concurrently. All right, so once you get the key idea, you realize these three questions are actually very similar in the structure. Okay, so first one, so we want to find the least value of n. Okay, so we are solving for n. What are we looking at? We are looking at the sum to n terms, so we are looking at Sn. Okay, and we want Sn to be within 2%. Okay, sounds like a mouthful. So allow me to just bring in a very simple idea. Okay, let's talk about English first. So the price of the burger should be within 2% of $5. So I will ask you, what is the price range of the burger? Okay, so for example, if I don't really know the price of the burger, but I say it's within 2% of $5. So what's the rough estimation of this price of this burger? Can you see it's going to be between $4.90 to $5.10, right? Because I take this as $5, and when I say 2%, I mean right? This gap over here, it's 2 over 100 of $5. And likewise, the same goes for this gap here. Okay, so why am I bringing up English? Because that will help you understand the question. So now, with reference to the question, I want Sn, right? So I want Sn. But what do I want about Sn? I want Sn to be within 2% of the sum to infinity. That means if S infinity is to be here, this is S infinity, right? Okay, I just put as 9/5 since we know the S infinity is 9/5. Can you see where Sn must be? Sn must be within 2%, right? So this gap over here is 2% of S infinity, and likewise this gap here is 2% of S infinity. So Sn must fall within these brackets. Okay, in other words, Sn are all like my targets. They must fall within here to fulfill the conditions. They cannot fall outside. This is not acceptable. Okay, so Sn are like my blue targets. All these are my Sn, okay, the ones in blue. These are all the possible positions of Sn. Okay, so how do I form an equation in this? Okay, you realize that I can look at the difference between Sn and S infinity. And can you see that the difference, the magnitude of the difference, the largest the difference can be would actually be 2 over 100 of S infinity. This value here, right? It cannot be larger than any of that. Okay? However, there's a possibility that this will be a negative number. But my focus is I just want the magnitude, right? I just want the magnitude of the difference between Sn and S infinity. And because of that, I throw in the modulus sign. Okay? Now, some of the concerns is, question is, why not? Why not the equality sign? Okay, and the reason is because of this keyword within. Okay, now I use football to explain to you. Now in football, okay, to score a goal, you must score within the goalpost. So if I got a football, okay, this is a football, and I kick the ball, it hit this pole and it come out. It's not a goal, right? Okay, so that's why we do not include the equality sign. Okay, so that's the idea of within. Again, English lah. Okay, so with this in mind, right, students, you can understand the same reasoning will go for the rest. Just that for the others, rather than it being a percentage, okay, so I'll just show you for the diagram for part 2. So the diagram for part 2 will look something like this. S infinity, and I want it to be plus minus 0.5. So where is it? It means that the gap here is 0.5 units away. There's no percentage this time. Okay, so I want to draw your attention to the key difference between the percentage sign, okay, and no percentage sign. Okay, and that is the crux behind these three sections. All right, so now let's go into the algebra. So I have already explained this part and it will be the same for the rest. Okay, so I'll just use one question to explain. You will see the other two questions, the ideas are the same. Okay, all right. So some of the key steps I want you to take note. I want you to pay particular attention over here. I did a few things. I use this property. First one is remember the modulus of AB. You can separate them into mod A times mod B. And that was precisely what I did here. Okay, so that is how I got from this step to this step. Okay, of course, I bring the 9 over 5 over. Next, again, a lot of things are going on over here. Okay, I did this. Again, I split this part into -1 power n and 2 over 3 power n. Okay, and you want to pay attention that this guy will always give you 1, right? Regardless of whether n is an even or odd number, whether you get 1 or -1, because you have the absolute sign, you make him 1. And that was how they conveniently got this. Okay, lastly, you want to pay particular attention to the change in inequality sign. Okay, because what are you doing in this step? In this step, you are dividing, okay, from here to here, you are dividing both sides by ln 2 over 3. And this is actually a negative number. So in inequalities, when you divide by a negative number, you have to change the sign. Okay, so if you understood this, okay, I ask that, for part 2 and part 3, don't look at the solutions next. You might want to pause this video and try on your own first. Okay, now I'm going to show you the solutions. Everything is the same, so I'm not going to reiterate anything here. Okay. The only thing I want to say is about presentation for set notation. If the question asks for set of values, there are 3 things. Number 1, okay, you need to show the category. Now, is it an integer? Is it a real number? Is it a positive integer? Is it a negative integer? So in this case, actually, if you want to be more precise, we know it's a positive real number. You could actually put a plus. Optional, but it's fine. I think that is being more precise. Now, second thing, dot dot. Dot dot actually just means such that. Okay, so this is the second thing. And then the last thing is what we call the condition. So this is actually the condition. Okay. All right. And then part 3 again, I don't need to explain now. It's the same idea. Okay. All right. So that's all for question 3. Okay. Thank you.